Hi, I'm Paqueta12, and today we play with springs. We'll recreate this file in which we have a grid of points, and every point is connected to the neighbors with spring forces. And we'll do this on GPU using only tops, and either you're a beginner, I'll do my best to give you a smooth explanation. And before we start, I would like to mention you this awesome tutorial by Daniel Schiffman, and here's a wonderful explanation of what's going on. Okay, so let's start. I will close this and leave it aside to guide me. Okay, I have a default file here, and let's start with a constant chop. Okay, and yeah, here we need the rows, the columns, and the K constant, which says about the elasticity of the material. So we good here with 0.125, and let's go with 16 for the rows and 32 for columns. Okay, and now use a null here. Okay, and now we'll drag the UV component. You can find this in a couple of my tutorials. Also, you can download this file. And let's set the resolution. So the columns goes for X and the rows goes for Y. Okay. We use a null, and let's go inside, and those two reorders. Okay, let's set them to 32 RG. Okay, we good. And now we can see this those points. Actually, it's a grid by instancing a sphere. So let's grab this end null. I will make this a little bit bigger. Okay. And chain a null here. Okay. Now I don't want the select being so big, so yeah. Okay. Now we good. And we use a sphere. And we go for the polygon frequency of 3 and radius 0.5. And now we use geometry and go for instancing. Take this texture into translate OP, and here we go with RG. Okay, now let's split the screen to see what we got. And obviously the spheres are way too big, and you can scale it down using a transform here. Okay, and yeah, you can make this how you want. Okay, but what I would like to do is to have kissing spheres. And so we need a precise scale value, and this one is 1 divided by the maximum of those two numbers. So if I say here 1 divided by 32, we good. And now I would like to have this value already computed here. So we use a null. Okay, and go inside, and here I select the rows and columns. Okay. Okay, I rename this to max, and yeah, now we use a shuffle. Okay, and sequence all samples, and now we have both of them into one channel. And now we can use analyze and take the maximum. Okay, we use a merge here, and we are good now. Okay, so let's take this max value here and go with 1 divided by max. Okay, now we're good. And since we will have those spheres moving, okay, what if we make them 3 times smaller? Okay, now we good. If we want to displace those points, we use again the display stop as in last tutorial. So let's insert a display stop here, and we know that we need a texture with 0 in 0.5 actually. So 0.5 will have 0 displays. Okay, so that means we need a noise texture. Okay, let's set the resolution, columns for X, rows for Y, and this has to be 32 Rg. Okay, and not monochrome. Offset to 0.5, amplitude to 0, and now we have this clean 0.5. Okay, if we put this here into second input and set the vertical source to green, we have no displays. Okay, if however we increase a little bit this amount, okay, we have something. And now in this position I would like to find out the spring forces. Okay, so we go 4 steps and find out the distance to the neighbors, to the top, to the bottom, right and left, and then we average those vectors and we get the final displace vector, which will go here and will have the elastic motion. Okay, for this let's grab this texture, okay, and chain a null, and in between another null to make a folder by collapse selected. Okay, let's have this a little bit bigger since is the main piece. Okay, and name this springs. Okay, now let's go inside, and in order to find the vector direction and the distance to the point to the left, let's say, we need to offset the UV with the transform. So let's offset this. I would like to see nearest pixels. Let's offset this to the left. Actually, it's offset to the right, okay, with 1 pixel. But now if I say subtract, and I have this offsetted UV minus the initial UV, then I'll have for each point I'll have the vector to the left. Okay, so I will rename this to left. Okay, and yeah, let's make this for any direction. So not any direction, we only go for top, bottom, left and right. So the corners, you can go with the corners too if you want. Okay, so here I would like to offset to the right by using -1. So okay, and now let's use the Y. Okay, so this is to bottom. Okay, and another one, it's to top. It's -1 here. Okay, we good. So now these textures with subtract contain the vector's direction. Okay, and let's find out the distance by using Pythagoras, which is encoded in MathTop, and we can go here with the length, mask the alpha, and set the 32 mono, and we have the distance. Now let's see the nearest pixels. You see this line we have to cut it out. Okay, now let's make this for all. And you can have 0 instead of this line by using hold here, but I would like to see that line in order to take it out. Okay, so right here in this moment we have the distance. Okay, now let's go a little bit back into this tutorial, and we have 2 points here. Okay, and a spring, and when it's displaced longer or shorter than the initial rest length, then the elastic force will come into play. Okay, so the force, it's actually this difference of from distance minus rest length. Okay, this is x, and then we only need to multiply with k. So it's very, very simple. Okay, so since we have the distance here, we can subtract the rest length, okay, from all by going here in post add and say -1 divided by. Okay, and now we good. And let's clean this this line. So I use transform. There are several ways to do this. Either you multiply with a texture in which you have only one, and you have one and only a line with 0, and you multiply, and you're good. But I will go with transform and offset this to -1, and again I offset back to 1. I mean back with 1. Okay, and in extend we use 0. So instead of this line, now we have 0. Okay, let's do this for all. Okay, so here let's reset this. We need to offset to -1, I believe. No, 1. Okay, and obviously here is minus. Okay, we good. And this one should go -1 here. Okay, and this one it's 1. Okay, and the last one. Okay, so we have 1, and here it's -1. Okay, and now we have a clean texture. Okay, with the amount to displace. we only need to find out the direction of displacement. So displace goes along a vector, and that vector is here in the subtract texture. And I would like to see it much better, since sometimes you need to debug, and it's good to see something. Here we have a bunch of values, and let's normalize this. Okay, we use a null and insert the null in between in order to make a folder. Okay, so this folder here, let's go inside, let's change here with out1. Okay, now what we need to do is use a math, and again go for length and 32 mono. Okay, nearest pixels, and now composite with divide. Okay, so we have divide and input 1. Okay, we see something here. Let's set these to nearest pixels. Okay, so we have something. Now we don't need this null. Okay, so once we have the normalized vector, it's like length 1. Okay, and it has a direction being 1. If we multiply with the amount we have here in this clean texture, that means that the vector become the length of this distance minus rest line, rest length. Okay, and yeah, now let's multiply like this. So we use multiply. So we multiply a black and white image, actually it's a scalar value, with a normalized vector. Okay, so we have this. Now let's do this for all the direction. Okay, so Control C, Control V. We good. We go from subtract. Okay, and use multiply. Like this, and yeah, let's go for all of them. So subtract goes here, and the multiplication, the transform texture here. Okay, so subtract goes into the normalize and transform into first input. Okay, now we are good. We have the vectors which acts on top, bottom, right and left direction, and in the end we need only one vector. Okay, so it's very easy to find out that by using average here. That's the beauty of linear algebra. So we use composite here. Okay, and we go with the average. Okay, now we have the elastic vector we need. Actually, we have to multiply this with the constant. Okay, so we use a mod, and let's multiply with k. Okay, and let's see. I would like to have this texture here into this place, but it has to be the same way as this noise, and so here the center is into 0, so I need to offset everything. So I use a mod again. Okay, and go here and say range this from -1 to 1 to 0, 1, and so you see we have a good texture now. And what else we can do, because we are almost there. There are several ways. Okay, let's make this moving by translate on Z with ABS time dot seconds divided by 20, let's say. Okay, so we have this motion. Okay, what if now I take this texture and compose it with the input noise? Okay, so I can use a feedback like this, in which I'll take this texture, okay, and in between those two, and not in between, but then I use composite or cross. Let's use cross, since by default it takes 0.5 and 0.5 from both. Okay, so we have cross, and yeah, let's go bigger with this one. Okay, now you see we have that noisy movement, but also half of the motion, it's driven by the elastic forces. Okay, and yeah, this is good. You can increase these rows and columns by a lot. This is very fast method, but instead I would like to make something else. Okay, so it's depend what you want. Okay, what I want to do is use a feedback. So I have one. Let's use it again here for the position. Okay, and yeah, let's have also keyboard in to pulse and reset the feedbacks. Okay, so one it's here and one it's here. Okay, and again for the other one. Okay, and in this feedback I will take this end texture. Okay, and yeah, now it's crazy, and we'll do something else, not using a cross. We'll have only this. Okay, and since this goes into a feedback, you can have just a second. So instead of this noise, let's go with a constant. Okay, not chop constant, instead constant top. Okay, so in this one we need the 0.5. Okay, it's just for initialize the feedback. Okay, so let's go for the same resolution. Okay, now this has to be 32 Rg. Okay, now we're good. We don't need this noise. Okay, and what we have here now, it's something that it ain't move. Okay, so we need a noise somewhere. Okay, and we have a couple of options. So you can use a noise here. Okay, by doing this, let's set the offset to 0. The amplitude is 0 for now. This is 32 Rg. Okay, and let's use for the amplitude, let's use this value. Okay, 1 divided by the maximum. Okay, and yeah, let's see how we are now. Now the speed is way too big, and this is because the amplitude here is the same as the initial distance between two grid points, and that is quite big for a smooth motion. And we can go here and divide by 100, okay, and yeah, we have something like this. And what else you can do is maybe, I don't know, let's bypass this noise. Maybe if I use a noise here, so let's go with the noise here to noise the elastic forces. I found this method much better, and again it has to be 32 Rg, okay, and offset to 0 amplitude. Let's take the same amount, okay, as here. Okay, and yeah, let's noise this and take the map coordinates. We can take from here, okay, let's go like this, you see, and yeah, we have this noise. This is static, okay. We can make it move by abs time dot seconds divided by 20, and now you have some nice noisy movement, okay. If you play now with the K, you'll see it gets more stiff, okay. So yeah, it's up to you how you play with this. However, you can take the coordinates map also from the initial UV. Okay, so let's have a select here, and we say take from UV1 out 1, okay, and we can use this one. Okay, it gets more uniform maybe as a distribution of points. Okay, what else we can do with this? So we have spheres. What if we connect the line in between some neighbor points, and we get a mesh like something? And luckily we have anything we need right here. So let's see. We need a line SOP, okay. Okay, and this line should be on z-axis, okay. Right now by default it's on x, so 0, 0, 1 here. Now we good, okay. And let's use geometry for this. Okay, let's go here, and I want to put these lines where I have the point. So let's use a select again, select top. We take this end texture and use a null, okay. And now let's use this null here. So we have R, G, and B. The B is it's 0, okay. Now obviously the length it's 1, okay. We have here the length 1, and I would like to put this line segment in between every point and the one to the right, okay. And I have that texture somewhere, so let's go split top and bottom, okay. I want to use a select top here, and let's go inside these spring folders, okay. Now I have the distance here, but I subtract the rest length, okay. Also I have this ugly line, and what if I take this clean texture, and from where? From the line to the right, so bottom right, this second line. So let's take this, okay? And we need to add back the rest line, the rest length, okay? Since now, if we use this texture for the, let me make some room, okay, for the scale, and go with a red value for the Z. Now we have something, okay? The lines, you see, are so small, actually, because the rest length it's missing, okay? So we can go here with matte, like this, and let's take the maximum and use it in post add. So I want to add back 1 divided by, okay? Now the lines are good, but the orientation is wrong. So I would like to have here in rotate 2, I would like to have a nice texture. So let's use a select here to bring that here, because since we already have it, okay? So I would need to go into the right line here. So go inside this normalize vector and let's grab this out, okay? We can grab this subtract, okay, also, but it's good to see what you're doing. So now let's chain a null, okay? Let's make this crazy color, since we use them for instancing, okay? And here I use this vector and go for pre-root and say R, G, and B. Now let's see what we have. Yeah, we have the line, we don't see them yet. Let's use a constant. Okay, so now we are good. Here is it's something at the edge to the right, okay? Since we put back the rest length, there should be 0, and it was 0 till here in the clean texture, and then we put it back. There are several ways you can do this. You can multiply. Actually, let's do that. So I use a constant. You can go again with translate back and forth, or let's use this. Let's give it a good resolution. So columns for X, rows for Y. This has to be, let me see, 32 mono. Okay, so now we good, and we have 0 here. So, yeah. And now we can use that transform with translate by pixel. Let's see this nearest. Okay, that's the -1 maybe. Okay, so now if I multiply those two, I should be okay. So multiply. Let's see. Yeah, the right edge, it's perfect now. Okay, so now we need to do the same for lines to the top. Okay, so let's copy paste this. Okay, and for this texture now I will take the top. So top is the bottom line. So let's take this, and here I will take this. Okay, yeah, something went wrong. I'm not sure why is this. So transform. Okay, and this has to be like 0 and 1. Okay. Okay. Null 10. Yeah, let me close this, because we are wrong somewhere. So we have the texture with the points. This is good. This is the length. The length is good here. Base 4. Okay. So this should be why is this is mono? It's not good. It's RG. Oh. Okay. Now we good. So we take the input from the math, and this one is mono. We need to take from subtraction. Okay. So yeah. Yeah, we are good. And let's see. Yeah. Now we have that little problem to the top. Let me check. And also the points don't take the orientation. Okay. So here's to the bottom. We need to the top. So it's -1. Okay. Now we good. Okay. So yeah, let's go crazy with this. Let's have 128 by 128, and yeah, you can have a million or two here. So the FPS will be so smooth. And this is how you do the elastic forces. Okay. Now, what if I would like to pin some points, some maybe regions from this grid to pin as they will stay there? Okay. So what we can do, I know, let's use a ramp for this. So we use a ramp, and the ramp should be the same resolution. Okay. Like this. And yeah, I don't know, maybe if we make some stable edge for all. Okay. And so I use this ramp. This should be 32 mono. Okay. And yeah, we good. Let's use flip and go for flip the X, and then again a flip, and go with bottom left, and another one go with top left. Okay. And now if I use a composite for all, okay, we can take the maximum, and we have this type of texture. Okay. So let's use a null, not a level, sorry. Okay. And we can play with this. So I would like to, let me use here another level to invert this. Okay. Yeah. Now I have 0 here on the edge, and here it's almost getting to 1, if I limit this, we can use limit and go for normalize. So I have 1 here. That means in the center, I'll have the elastic and the motion, okay? And for the edge, they will stay still. So let's see how we do this, okay? I believe I would like to multiply this with a constant. Let's use a constant like this. Not chop, sorry. So constant top. Okay. And let's set this value to 0.505. This is 32 Rg. Okay, and so I have this constant. Doesn't matter, the resolution can be 1, okay, since we multiply this, okay, with our texture, and it takes the resolution from the input 2. Okay, now I would also like to have not mono, I would like to have RGB, but now yeah, let me set the resolution here. It's much better, because now we can do this and we're good. So right now I want to use reorder. Okay, since I want, instead of the black, I want the transparent. Okay, so I take from here, I'll take the input 2 and red, and this has to be RGBA. Okay, and now I have this. Let me see if yeah, now it's better, because if the 0.5 green doesn't have any displays, so I would like to have that value next to the edges. Okay, now from here I use over, and I over this texture above the one with the elastic forces. Okay, and go like this, and now you see everything stay still, you know, and only the middle it's moving. So as you can go like I don't know, like this, and you'll have only one part, so it's looking more like a flag. Okay, so yeah, this is easy way to play with this. What else I would like to show you is okay, we can compute the elastic forces quite fast here, and so we can go up with crazy numbers of rows and columns. Let's say 1024 by 1024, and that would be 1 million, and we don't want to instance 1 million spheres, since you will most likely lose the FPS. Okay, what if instead we go higher than 1024 and don't use instancing at all? Okay, let me show you. Okay, so for now, just for, let's bypass this. Okay, and also this one. Okay, and let's go with this resolution as 1920 by 1080. Okay, and now actually it's the other way, 1080 and 1920. Okay, now we are full HD, and we have this texture. Let's select this, texture. Okay, and you see this texture, it's going on. Okay, in a while you'll see some little mess here. Okay, and now what if I would like to remap something else? I know, a movie input, an image, and so on. And I have here an old image. Okay, so let's play with this one. First of all, this is square, and I would like to stay in a full HD. So let's use a fit here, and we'll go for the fit outside. And here in the resolution, let's take this. So this goes for Y, and this for X. Okay. And maybe, I don't know, translate a little bit down. Yeah, like this. Okay. Now, what if I would remap this with this texture? So let's try. So first of all, you see some stretching. Okay, and this is because when you use remap, okay, in that texture it has to be all the values in between 0, 1 on the X and on the Y, and here on the Y we have less. Okay, so now if I use math and I want to multiply on Y only, so I mask anything else. Okay, you don't need to mask the Z. Okay, this is only RG texture, and I'll multiply by 1080 divided by 1920. Okay, now I guess it's the other way. Okay, now we go. You see now the UV, it's getting all the values from 0 to 1, and yeah, when you instance, this is not so good, since you'll have a square. Okay, okay, but yeah, let's see this image a little bit. So it's way too big. Okay, and play with the noise, I believe. Okay, so yeah, obviously we don't need this edge pin. Okay, so yeah, let's get rid of this, and now we're good. And the amplitude is 0. Let's say 30. And yeah, you see now the elastic forces are doing the job inside the texture, and you can get some very nice glitches. Okay, so yeah, you can go quite crazy with this. And yeah, this I believe I covered anything I intend for this tutorial. So yeah, this is it. I really hope you like this, and so hit the like button if you did, subscribe if you haven't already, or you can support me on Patreon. You'll get access to a bunch of other tutorials, and you'll help me go on with this research on computation with textures. I want to thank to all my patrons, especially to Anti-Allies, Brandon Tay, Breakwood, Brian Smith, Conor Carnes, Daniel Clark, Darian Brito, Dimitri Diak, Doya, Farhad Forodi, Fraxinus, Kevin Greber, Leo Torres, Moreno Belic, Priam Givord, Robert Elderton, Robert Love, Swild Bridger, Siskil Me, and Vincent Nepals. Guys, thank you so much.